Now let's start out with some repetitions. Let's say that you have the positive integers 1 to 5, and you want to see how many positive odd numbers you can make from them. Now the key word in this question is odd, because this means that the last digit of each of your numbers will have to be 1, 3, or 5. So in order to do this, I'm going to add up all the possible 1-digit numbers, the possible 2-digit numbers, the possible 3-digit numbers, all the way up to the 5-digit numbers. So as I stated before, all the last digits will have to be 1, 3, or 5, which means there's 3 possible numbers that can be there. But for everything else, since it just asks how many numbers, we can repeat. So any of the other places can have any number from 1 through 5. So there's 5 possibilities for each of those blanks. So we can just multiply all the place values together in order to get all the possible 1-digit, 2-digit, 3-digit, and so on numbers. So let me make this a little easier to visualize. So I'll pick one of them, the 2-digit numbers. So you have 5 choices for your tens place, but for each of the numbers that you choose for the tens place, you also have 3 other options, 1, 3, and 5. So there are a total of 15 possibilities that you can make. So you can repeat that for each of these other numbers. So the numbers in the blanks are not the actual integers that the problem asks for. They are the number of choices that are available for each place value. So for example, for that tens problem, there would be 5 choices available for the tens place and 3 choices available for the thirds place. Anyways, when you add up all the possibilities, you end up with 2,343 possible numbers. Alright, how about another question? How many different 4-letter arrangements can you make if the third letter has to be a vowel? So that's the important part of this question. The third letter has to be a vowel, which means that the third blank can only have 5 options, A, E, I, O, or U. However, since the question doesn't say that the other 3 blanks can't be vowels, then each of them has 26 possibilities, A through Z. So if you multiply them all together, there's 87,880 total possibilities. So before we go into the practice problems for permutation, I'm going to go over some special cases of permutation. So these are situations where the normal formula does not apply. So the first type is circular permutations, without a frame of reference. So let's say that you have a round table at a birthday party and there's 8 people sitting around it. So if you were just going to look at it from this perspective, then there would be 8 factorial ways to arrange them inside the circle. But if you were to turn the whole table one person clockwise, then you would still have the same order, but now it would be facing a different direction. And if you repeated that, there would be 8 different sets of that 8 factorial. Without a frame of reference, you have no way of knowing what orientation it's in. So therefore, in order to prevent creating a lot of unnecessary permutations that are basically repeats of everything except in a different orientation, you have to divide by n. Let's say that you decided to be a weirdo, and then you stand right in the middle of the table and stare directly at person number 1. If everyone decides to move one seat clockwise, then you can immediately tell that you aren't looking at person 1 anymore. Now you're looking at person number 8. So therefore, if you have a frame of reference, like any place where you can look in and see the orientation, then that turns it into a linear permutation, and you don't have to divide by n. Now our next special permutation, reflective, usually goes hand in hand with circular permutations. It's usually applied to circular objects that can be flipped around, such as a ring of keys or this necklace with 4 beads. So if you were to flip this necklace towards you, then you would see that the resulting order of the beads is the same, except now, again, it's in a different orientation. It's been reversed. So since reflecting it results in 2 identical orders that are just in different orientations, you can just divide by 2. Alright, so our last special permutation is identical elements. So this is applied when a set has multiple elements that are the same and you want to create permutations from them. So let's say we have the word apple. The word apple has 2 P's, and if you were to arrange them, you'd eventually run into a situation like this. So as you can see, we've ordered the letters so that they spell A-L-E-P-P, but you can see that there's 2 different orders because the P's can be arranged differently. There's 2 P's, which means there's 2 factorial ways to order them. So if you have n1 identical elements, there's n1 factorial ways to arrange them. So to prevent unnecessary permutations, you just divide by n1 factorial to get rid of all the extra orders that have the same letters. And you would repeat this for each group of identical elements. Alright, finally on to our practice problems. So we want to find out how many different arrangements, without repeats, of the letters in the word ugly we can make. So there would be 4 numbers in the set, and 4 that we're taking at a time, so it's just 4 factorial, or that's 24 different arrangements that we can make. How about the word treble? So the word treble has 2 E's, which means that they're identical elements, so we would take the permutation 6 factorial, but we would have to divide it by 2 factorial for the 2 E's. And then that gets 360. Alright, on to the next. Let's say that three families, each consisting of three people, arrive at a party and they want to sit down. How many ways are there to arrange them so that each family is together? So now we're going to introduce the concept of grouping. So in grouping, there's ways to arrange the elements inside the group as well as the groups themselves. So in this case, there's three people inside each group, so there would be 3 factorial ways to arrange them inside. But there's also 3 groups, so there's 3 factorial ways to arrange the groups. The arranging of elements inside a group is called the intergroup arrangement, and between the groups it's called intergroup arrangement. So here, there's 3 factorial ways to arrange each family, 3 times 2 times 1, but there's also 3 factorial ways to arrange each of the groups, since there's 3 blanks. So you would multiply everything by 3 factorial once again. And if you solved it all, then you would get that there are 1,296 ways to arrange them. Okay, so a necklace has 4 identical red beads, 3 identical yellow beads, 2 identical blue beads, and it doesn't have a clasp. And we want to find out how many distinguishable ways we can arrange the bead. Now it's a necklace, so it's going to be circular, and it also has no clasp, which means it has no frame of reference. It also has identical elements, and being a necklace, it's going to be able to reflect as well. So it has a bit of everything. So first we just take the total number of ways we could arrange the beads. So first we take the total number of permutations, 9p9 or 9 factorial, and then divide by all the other things. So we divide the fact that it's reflective, which is 2. We divide by each set of identical elements, which would be 4 factorial, 3 factorial, and 2 factorial. And we divide by n, which is 9, because it's circular. So if we figure this all out, then we get that the answer is 70 ways to arrange them. Alright, on to combinations. So let's say that we have a deck of 52 cards and we choose 6 randomly. We want to find out how many of these 6 card hands will have at least 4 spades. So at least 4 spades means that it has exactly 4 spades, exactly 5, or exactly 6. So since there's 13 total spades and we're taking 4, 5, or 6 at a time, that means that we're going to be taking 13c4, 13c5, and 13c6. But if we take 4 or 5 spades, we're still going to have 1 more or 2 more cards that we need. So there would be 39 other cards, the aces, clubs, and the hearts, so we're going to take 2 or 1 of those. So you can see that we're either taking 4 spades and 2 other cards, 5 spades and 1 other card, or 6 spades out of the 13 total spades. And if we add up all the possible arrangements together, then we get that there's 581,724 possible hands. So I'll just draw this out and maybe it'll be a little easier to see. So we're just picking 6 random cards, and it doesn't matter what the order is, we just want 4, 5, or 6 spades, and we want to see how many hands are going to have this number. Alright, on to the next. Let's say that we have the word unlucky, and we want to take 3 consonants and 1 vowel and see how many distinguishable 4-letter arrangements we can make. Now the word distinguishable, even though I forgot to write it here, is very important because after you take the 3 consonants out of the 5, you technically have 2 vowels to choose from, but they're the same. So if it just said how many total arrangements that you can make, allowing repeated arrangements, then you wouldn't have to do this. But since there's 2 U's, you might end up with a situation where you have 2 of the same arrangements with different U's, or you have 2 different U's in the same arrangement. So therefore, you only have really 1 vowel that you can choose from, and you multiply that by 4 factorial since there's 4 factorial ways to arrange the letters. Now multiplying by 4 factorial seems a little strange at first because it looks like there's 2 groups, not 4. But think about it this way. When you take a permutation, you're taking an order, and those elements would be stuck together. They're stuck together in an order. When you take a combination, on the other hand, you're not taking an order. You're kind of creating a smaller set by taking elements from the larger set. The letters aren't in any specific order, they're just there, and you can move them wherever you wish. Each of the elements in the combination is its own individual element, as opposed to a permutation where each element is a part of a larger group. So if you multiply it all out, you get that there's 240 different arrangements. So if you had taken a permutation of those 3 consonants, then you could only arrange with either the consonants first in a group of 3, followed by the vowel, or the vowel first, followed by the group of 3 consonants. So there would be 2 groups, and you could arrange inside the group of consonants however you wished. But here, you're taking a combination of consonants, and therefore you can arrange the consonants and the vowel in any order. So you could have consonant, vowel, consonant, consonant, or consonant, consonant, vowel, consonant, and so on. So if you guys have any trouble with this, I highly recommend that you actually pay attention in class like you're supposed to be doing. So that was repetitions, combinations, permutations. Please get good.